As an introduction to chemical equations, where we start talking about atoms and what's occurring on an atomic level, let's reiterate what we talked about as far as chemical reactions. Okay, so a chemical reaction, we saw in the previous video that one thing that we know when a chemical reaction occurs is it produces one or more new substances. Okay, so that's what defines that we have a chemical reaction, chemical change. It's because we're producing something new. And we saw that we can observe those in some new physical property that we see. So an example is if you take these antacid tablets, which are sodium bicarbonate, you put them in water, and they form bubbles of carbon dioxide. That's a chemical reaction. Okay, so we're going to represent that by a chemical equation. So we're going to start learning how we write chemical equations, how we represent the different chemicals that are reacting together, and then we'll learn about how to balance chemical equations. So for this video, we're just going to talk about the introduction. So we know that a chemical reaction, it involves the rearrangement of atoms. So from earlier atomic theory, we know that atoms aren't created or destroyed in the process. So the atoms that you start with are the atoms that you finish with. They're just rearranged into new and different compounds. So what we're going to find out is we need to be able to keep track of what we started with and what we end with, and make sure that we haven't created anything new or destroyed anything. All right, so we're going to represent that chemical reaction by a chemical equation. So our chemical equation, and I'm sure you've seen these before, is written out in a very specific way, and we'll go through the details of this in just a moment. So it's a concise way for us to represent what is happening in the chemical reaction. So when I have methane, which is this molecule here, and I mix it with oxygen and I spark it with a flame or spark it with a spark, I get a constant flame, which indicates that I have a chemical reaction, we get a lot of heat given off, and I'm creating two new things. Now, we don't see those new things in this particular case because they are both gases. So we're creating carbon dioxide gas and water gas. So when you're burning methane, you're combining methane with oxygen, and we're creating these two new substances, carbon dioxide and water. So we show that representation in an atomic scale with these little ball models that we've seen before, where methane, which is carbon with 4 hydrogens on it, combines with oxygen in a specific way. This is oxygen with 2 oxygen atoms, burns, and then we create something brand new. And here's a water molecule with 1 oxygen and now 2 hydrogens, and we create carbon dioxide, which is 1 carbon and 2 oxygens on it. All right, so let's start breaking down what we have in an equation for a chemical reaction. So in our most basic form, what we're going to see is we're going to see that these things that are reacting together, so the two things on the left-hand side, whoops, just a second here. All right, there we go. All right, so the two things on the left-hand side of the equation, these two things, we call them the reactants. Okay, so those are just our general things. Those are the things that are reacting together. There are starting materials. And the things that we create, those are our products. So we have reactants combining together to create products. And this is what we call the yield sign. So we say that these reactants yield these products. So they combine to yield some new product. So in our chemical equation right now, as we see it on the screen now, we're just describing, here is a certain compound reacting with another compound, methane reacting with oxygen, and it's yielding this new compound, carbon dioxide and H2O. So this just gives us a general idea. When we react these two things together, this is what we're going to produce. The second thing to note in our equation, in this case, is we also have these letters in parentheses after each one of our reactants. And what those are the physical states of the different compounds that we are either reacting or producing. So in this case, we have methane gas reacting with oxygen gas to form carbon dioxide gas and water gas. So we have a list of these different types of physical states, and they're the three physical states that we know of, and then we'll have an additional one that we're not as familiar with, and I'll write that in just a moment. All right, so I switched over to make this a little easier to draw. All right, so in our chemical equation, we're going to indicate what the physical states of the different compounds in our reaction are. So our physical states that we're going to use these as parentheses around a letter or a series of letters. And when we have the physical state of something that is a solid, we indicate with an S. Physical state of something is a liquid, we indicate as an L. Physical state of something as a gas, we indicate as a G. And then we have this new one that we haven't seen yet before. And what that is AQ, and that means aqueous. So what that defines is if it's dissolved in our solution. So when you think about an aqueous solution, that would be like salt water. Salt in water, salt is dissolved in water, and we want to indicate that as an aqueous solution. So it's not a liquid per se, but it's actually salt that is dissolved in water. So it's its own thing. And we're going to see that quite a bit when we talk about aqueous solutions. So an example is the seawater mixed, or salt water mixed with silver nitrate. Both the silver nitrate and the seawater are aqueous solutions. So there are dissolved solids in those solutions, and then when they combine in a chemical reaction, they form a solid that we saw. The solid that in that particular case is silver chloride. Okay, so we're going to use these to indicate the physical states of the things that we are combining in our solution, or in any chemical reaction. Sometimes you may also see above the yield sign, we'll put things up here. And for example, if I put a little delta, that equals heat. So in other words, if I combine these together and they form heat, or I have to heat them, we put a little delta symbol over the yield sign. So you'll see that. And occasionally there's some other things that we'll come across, and we'll define those as we go. But sometimes in our yield sign, we'll put things over the yield sign to indicate we've done something during the reaction, maybe to help it out or something along those lines. All right, the second thing that we want to be able to do is, for our equation, we want to be able to either read out how that equation reads just in text, or we want to be able to take some text and be able to write an equation from that. So let's look at how we would go about doing that. So in this case, what we're going to say is, okay, here's our compound, methane gas. So we've got this component, methane gas. Then for the plus sign, we say what that's doing is reacting with. So methane gas reacts with, and then we read out this is oxygen gas. Then we use the term to produce. That's our yield sign. So it's producing something new. And we're saying carbon dioxide. Oh, I didn't put gas, but we should have carbon dioxide gas and water gas. Okay. So if I'm given an equation, or if I'm given something that reads out, I'm going to take out these things. I should be able to look at my written statement, and once I know how to write all the different components of it, all the different chemical compounds, I should be able to read it out and produce from this an equation. So if I was given this equation or this sentence, methane gas reacts with oxygen gas to produce carbon dioxide and water, I should be able to start writing the equation out in a form that we can take this sentence and combine it into a more concise way of representing that chemical equation. So we'll get some more work on doing that type of thing. But the next thing that we're going to talk about is balancing of chemical equations. So that's our next topic.